I'll just keep it. This is exercise 6.2, question 36. Someone was just asking for part B. If we've got the D equals 5 over tan alpha, we have to come up with an expression for D alpha. Now, you can do this two ways. You can treat that as 5 times tan alpha to the negative 1 and differentiate like that. D alpha would be 5 times negative 1. What do you get? Tan alpha to the negative 2 times, differentiate tan, and you get sec squared alpha, which is, what do we get? Negative 5 over tan squared alpha times sec squared alpha. So we should change the tan and the sec into their cos, sine, whatever they are. So tan squared, isn't that sine squared over cos squared, times sec squared, that's 1 on cos squared. Please do not go cancelling at the moment. Like, it might work, but I wouldn't be guaranteeing it. This is 5 divided by that, or you could have written the tan squared as cot squared instead, and cot is cos on sine. That's probably better. 1 on tan is cot. Don't worry, you like it the way it is? So what's this? Negative 5 divided by that. So what do I write? Negative 5 times, are you okay with that? Because it's negative 5 divided by that, so it's negative 5 times the reciprocal times 1 on cos squared alpha. Are we okay with that? So the cos squareds do cancel, but I would have just been very very careful doing it there. So they do cancel, only because there are multiplication symbols between everything. So we've got negative 5 over sine squared alpha. Okay? Be really careful with that. The other thing you could have done from here, which is probably a better thing, 1 on tan is cot. So write this as negative 5 cot squared alpha times, wait, I know I'm off the page. So the other thing you could have done was, from there, this is negative 5, 1 on tan is cot. So write it as negative 5 cot squared alpha. Now cot is cos on sine. And sec is 1 on cos. It is the same, but you don't have to do this divide by fraction, okay? Which is just the coses cancel and you get negative 5 over sine squared alpha. Okay. Yeah, 1 sec. A spherical bath oil capsule dissolves, so it's spherical, so that the decrease in volume, so we know that volume is 4 on 3 pi r cubed. That's our first formula. We may as well do dV/dr while we're here. dV/dr is 4 on 3 times 3 pi r squared, which is, the 3's cancel, dV/dr is 4 pi r squared, which happens to be the surface area formula. So, a spherical bath oil capsule dissolves in the bath so that its decrease in volume is proportional to the surface area. So, dV/dt is proportional to, so equals K, some constant, times your surface area. It's negative as well because K, look, if I put a negative here, then K will be positive. If I don't put a negative there, then K will be negative.
Can you just say it's equal to S?
All right. No, this is what, look, in year 10 and in the general course, you would learn to write that like this. dV/dt is proportional to S. You okay with that? dV/dt is proportional to S. Well, that's what it's saying. The change in volume is proportional to the surface area. Then, no, that's a proportional symbol. And then you change the proportional symbol into an equals K. All right? Look, you're supposed to have done it, I don't know. Maybe not. 2 triangles are proportional. Isn't one just an enlargement of the other? Isn't the side length of one side just maybe 3 times that other one, or some constant times that other side length? Does that make sense? With triangles that are in proportion, or shapes that are in proportion, one side length is obtained by timesing the corresponding side length by some constant that you would find out. Might be times 2, times 3, times whatever. So if the change in volume, it says that the decrease in volume, so I'm assuming that's the rate of change of volume, is proportional to the surface area, it equals a constant times the surface area. Now, because it's decreasing, we go equals negative k. Or if I don't put the negative, k will be negative itself. If I put the negative here, then k is going to be positive. Okay? So it doesn't really matter if I put the negative in or not. It'll sort itself out, maybe. If its shape remains spherical as it dissolves, show that the radius of the capsule will decrease at a constant rate. You have to show that dr dt is constant. Now, what's the surface area of a sphere? 4 pi r squared, and we may as well do ds dr while we're there, which is 8 pi r. All right, let's come up with an expression for dr dt. Dr dt equals, any r's? Dr dv, I'm thinking, or ds. What? We don't have any other s's. And I can change this s to a 4 pi r squared, you know. S is 4 pi r squared, so I can do that. So yes, so dv dt is negative k times s, which is negative k times 4 pi r squared. So now I've got an expression for dv dt, ds dr, dv dt, dv dr, for all of them. So dr dt is dr dv times dv dt.
So really the dsdr.
We didn't need, but I just did it. So dr dt is dr dv, which is 1 on 4 pi r squared, times dv dt is negative k times 4 pi r squared. And the 4 pi r squareds cancel, and you get negative k. So therefore, the radius will decrease at a constant rate. So it's important to put the negative in because you were given values. If you were given values at specific times, like the volume was this initially and then it was that, and you didn't put the negative in, then your k should turn out negative if it. Therefore, radius decreases at constant rate. Good question. Okay.